All right, so welcome back, everyone. So in this chapter, we're going to be discussing memory, which of course is related to the last chapter of learning. Okay. So let's discuss, first of all, what we mean by memory, right? So we use it all the time. What do we mean by this term memory? So memory defined is the persistence of learning over time through the encoding, storage, and retrieval of information. And we're going to define each of these aspects of memory here in a minute. But the persistence of learning, right? So after you have learned or acquired new information, that information it is stored in the brain, right? So the brain has this, it has this physical component in which it actually physically stores the memory, right? But uh, again, it is this persisting, enduring information, right? Can be conscious, right? Memories can be conscious, they can be unconscious. We'll dive into that. But yeah. So one common misconception is that memory does not work just like a computer. And so for the longest time, that has been used as an analogy, right? So you have information coming in, it is stored, and then, eventually it can be recalled at a later point in time. But we understand that memory doesn't work like a computer, right? So for instance, I want you to imagine you type a paper and you save that Word document. What would you do if whenever you open that Word document again, you saw that your paper had changed? So words were different, there were things that were missing and so on and so forth. You'd be pretty upset, right? Computers and brains just work differently. Computers are infallible in that regard, basically, for the most part. Whereas memory involves this reconstructive process. We understand that memories are fragile. We understand that memories can become corrupted. They can have details that are incorrect. Generally speaking, when it comes to memory, we remember the gist of things. So kind of like the main central details. But peripheral details are much more likely to fade, especially with time. And so it's for this reason here why I have this puzzle, right? So again, you kind of like almost puzzle together memories whenever you recall them. And one thing's for certain is that whenever you recall a particular memory, it is not in its exact form as it was initially whenever it was first created, that first memory. Okay. So let's talk about the three stages of memory, which I just discussed, which are encoding, storage, and retrieval. Let's talk about those and let's differ between those. So memory, again, our ability to have this like enduring learned information. Encoding, that refers to basically acquiring new information, okay? So this is whenever you first come into contact with new information and you're getting it into your memory system. So for instance, whenever you're reading a book, right? You are processing the words on the page, you are processing the words meaning, what's known as semantics, and you are trying to form this new stable memory, okay? But importantly, you don't just encode whatever you're reading. I'm encoding all sorts of things right now, right? So I see things in my visual environment. I hear things. I have all these incoming sensory information, right? And that some of that information is going to be encoded and it's going to try to be converted into a long-term memory. Storage. So storage refers to the maintenance of this information. So again, we understand that the brain is the hardware. It supports memories. And so some important information is selected and it is stored for later retrieval. Retrieval refers to the recalling of that information, right? So that's a very important part of memory as well, right? So that's the process of getting information out of memory storage and being able to hold it in our mind's eye, at least temporarily, right? So let's dive into these specific memory stages, starting with encoding. So encoding, getting information into memory. Importantly, encoding requires some level of conscious attention, okay? So most of the information that we encounter are never fully encoded. And so I mentioned kind of like the bombardment of sensory signals. Only some of that information is actually going to be encoded and attempted to be converted into a long-term memory, okay? And again, one important thing in the encoding process is its importance or its salience, right? So we tend to encode important things that we deem to be important to us and we might want to know for later, whereas things that are completely useless to us, we don't really encode all that well. So for instance, take the following example. Here on the screen, you see 6 different variations of a penny. And each you see Abraham Lincoln, but you'll notice some slight differences between all 6 of them. So for instance, A, we have United States of America, liberty over Abraham Lincoln's right shoulder, the year over his left. Here we have in God we trust over his head instead of United States of America. Here we have E pluribus unum over his right shoulder. Here we have in God we trust, but we also have 1 cent beneath Abraham Lincoln and liberty over his right shoulder. The year over his right shoulder, liberty over his left, and in God we trust. And then finally, the last variation, in God we trust, liberty over his head, and then the year. Which penny do you think is correct? There is only one correct penny. If you said penny letter B, you are correct. Probably a lot of you got that incorrect. Don't feel bad. It's just that this wasn't important to you. Why would you need to know what a penny looked like? It had no importance or salience to you whatsoever, and so therefore it was never fully encoded, and therefore it was hard to retrieve that information, right? So encoding is that first initial process whenever you are coming into contact with that new information, right? So, you know, if I had a penny in front of me, I would be studying that penny and I would be trying to encode that information. But again, I'm kind of touching on this point or alluding to this point that we can encode things to varying degrees of quality, if you will. Okay? So that kind of ties into this next slide here, which is known as the levels of processing theory. So the accessibility of a memory depends upon how well that information is encoded. Information can be encoded either at a shallow level or a deep level. Okay? So shallow encoding. This is where we pay little attention to the meaning. We might focus on physical features instead, and this might result in a poorer memory. So as I mentioned, meaning is important in memory. Okay? So if you just focus on like superficial details of something, you're not going to encode that information very well. Deep encoding, on the other hand, you know, we pay close attention to meaning, and that results in a better memory. So continuing on with this discussion of encoding, we'll eventually get to storage and retrieval. So those 2 other related processes related to memory here in a minute. Let's talk about something known as encoding specificity. So there's some really interesting research that shows that we're more likely to remember something whenever conditions at encoding match conditions at retrieval. So whenever you first are studying information and whenever you're trying to recall that information, if conditions, either internal or external, match, then we're more likely to have a successful memory or a successful retrieval. So we're going to talk about 2 concepts here next, what's known as context-dependent learning. Here you see a picture of a scuba diver. We're going to talk about a scuba study in relation to context-dependent learning here in a minute, and something known as state-dependent learning. But these are both relevant or types of encoding specificity. We're going to dive into these concepts here next. Context-dependent learning. What that refers to, context-dependent learning, is external conditions. So when external conditions match at encoding and retrieval, that, as we find, is more likely to lead to a successful memory, successful retrieval. So there's a researcher by the name of Alan Baddeley. He's a very famous memory researcher. And he did this really interesting, unusual experiment back in 1974. He had a group of participants And he initially divided this group of participants into two different groups. So group A was to study a series of word lists while they were on land. Okay, easy enough. But they were told that they were going to be tested for their memory later. Group B, they were to study word lists underwater. And so they were strapped up with scuba gear and they went underwater and they studied word lists underwater. And so they're presented with these word lists and they're trying to encode this information. So those two initial groups were then subdivided into two smaller groups. And so we had a total of 4 conditions in the study. So in the land group that I just described first, half of those participants were tested for their memory on land and half were tested on underwater. So they were strapped up with scuba gear. Same thing for the scuba encoding individuals. So half were studying on land, half were studying underwater. And here we see the results here in this graph. So we see encoded on land as indicated by the yellow line, encoded underwater by the pinkish purplish line. And here we see the results for recall. So recalled on land, recall on water, and the y-axis percent recalled. So we see that if the information was encoded on land and it was recalled on land, this led to really good performance. Similarly, encoded underwater and recalled underwater performed very well. But if there was a mismatch of conditions at encoding and retrieval, as we see for these 2 dots here, that led to poor memory performance. So context-dependent learning. When encoding and retrieval conditions match, that's a good thing. That leads to better memory. Context-dependent learning, we're talking about external conditions. So here we're talking about the environment. In the case of state-dependent learning, however, which I just discussed, so I'll go back to the last slide. State-dependent learning, that's referring to internal states. So it could be mood, it could be how much caffeine you had that day. Kind of a similar idea though. If you drink a lot of coffee while you're attending lectures, it's probably best that you drink a lot of coffee too whenever you are being tested on that material. So encoding and retrieval. If you're in a bad mood while you're studying, it might be best to be in a bad mood whenever you're taking a test too, right? So state-dependent learning referring to internal conditions, context-dependent learning, external conditions. Okay. Let's move on to the next memory stage, which is that of storage. So that's keeping information in memory, right? We understand that information is stored in a hierarchy or a web. Okay, so for instance, consider the web of insect, right? We have all these concepts that are related to insect. So for instance, insects, an insect is an invertebrate. An insect can fly, it has wings, right? A dragonfly is a type of insect. So we have this very elaborate web of knowledge, right? That is how information is stored in the brain. It's like this network, basically. So if I were to ask you to imagine a giraffe, you're also likely to probably think of related animals such as, an elephant or other animals that you would expect to see, say, in African Serengeti or something like that, right? So that is storage. And finally, let's discuss our final memory stage, which is that of retrieval. So this is this reconstruction of information from memory. Again, emphasis on the word reconstruction. Memory is never perfect. Whenever we retrieve information, it is never in its perfect form. Every time you retrieve a memory, it is in a slightly different form as before, which is super interesting. Whenever we forget things, it's often due to an error in retrieval. So we just cannot grab that information from the depths of our memory. And whenever we're trying to retrieve information, we oftentimes rely on cues. Whenever you're encoding information, you are surrounded and you're in this particular environment. You've encoded that information. for instance, if you were to like lose your car keys, you're probably going to mentally re-walk through all these different places. You might actually physically walk through all the different places it can be, hoping that it will trigger a memory response. But retrieval, again, oftentimes relies on cues. A story I always tell is that I always notice during tests, whenever it's face-to-face classes, I always find that students like stare at me very intently sometimes whenever they're taking tests. They're just staring at my face. And I know what they're doing. They're trying to use my face as basically a memory cue to kind of shake loose that memory. So that's all we have in this video. In the next video, we're going to talk about different types of memory. So that includes sensory memory, short-term memory, and long-term memory. We'll compare and contrast. And so that's what we have to look forward to.